Hello everyone, and welcome to Module 7 of INST728E. In this video, we'll be talking about geospatial processing, specifically extracting GPS and location information from tweets posted to Twitter. Now what this means is we will be able to take a tweet or some sample of tweets, extract metadata from this tweet to identify where that tweet was posted in the world, and then we can post this information or graph this information on a map like we see here. Social media content with GPS coordinates, which is what we'll be able to use to identify specific locations where tweets were posted from, are very rare on Twitter, accounting for only 1 to 3% of tweets posted. However, we can look at tweets that contain place information or reference a particular city or region or area or country, and we can use that information to infer where a particular tweet was posted from as well. So we'll talk about how to do that, how to filter based on a particular area. So you can look at tweets that are within a particular region versus tweets that are outside of that region and identify what differences there are between these geolocated tweets. Now, why is this important? Because location information can be useful in data storytelling or digital storytelling and getting some insight into how people are responding to a particular event. So here, this was a really good visualization about how social media responded to the grand jury's decision not to press charges against a police officer who shot Michael Brown in Ferguson, Missouri. Now, the yellow dots represent where a particular tweet was posted from, and we see a bunch of tweets referencing Ferguson posted from all over North America, and when the grand jury decision was released, we see a massive uptick, and we can see where they're posted from as well. So they're primarily posted from the Northeast and from the West Coast, with relatively few tweets in the more sparsely populated regions. So some information that we will need in order to do this analysis is a GPS bounding box. Now, what this refers to is a location or a square on a map that lets us focus in on some particular area within this square. So since we've been looking at the Brussels transit bombing, we will be looking at a bounding box surrounding the city of Brussels. How do you come up with a bounding box, or how do you figure out what a particular bounding box is for a location? There are a lot of websites out there to help you with this task. One is called boundingbox.clocantech.com, which we'll go through here. Basically, you can go to this website, identify a particular place using Google Maps, and then it'll show you that city or that location. And you can draw a square or a polygon on the map. And then down here at the bottom where it says copy and paste, you can select several different formats to get out the GPS coordinates for this particular bounding box. Now, what this bounding box shows us down here is 4 numbers that correspond to the latitude and longitude of the lower left corner and the upper right corner, as we saw in the original base map example I showed you several modules ago. So what this says is Brussels is 4 degrees east by 50 degrees north. This is this point right here on the square by 4.48 degrees east and 50.9137 degrees north, which is up here, this point here. So you can do this for any location or any city and build your own bounding box. And this is what you'll be using, the event data map that we've been using so far. Now, once you've done this and run the Module 7 notebook, the homework for this module is very similar to the homework for Module 6. Basically, what I want you to do is build a visualization of where tweets were posted from during your event. They'll come up with the bounding box that is relevant or related or counts for where your event or your disaster took place, and then identify where in that bounding box tweets were from, or at least some sort of visualization about where in the world tweets were from if you have trouble with the bounding box issue. And then for extra credit is to build a temporal visualization of these tweets, similar to the Ferguson one I showed you at the beginning of this video. Okay, so now we'll move on to the notebook example. So we'll come over here to our list of modules, click on Module 7. So the questions that we can answer with this are questions like what content is being posted from disaster locations. So you would expect that content posted from the disaster or the immediate area around the disaster may be different than the sort of thoughts and prayers that we see in content posted away from the event. And we can also look at visualizations about how these tweets are placed in the world. So we'll have a couple different packages we'll look at, the sort of standard packages that we've seen, datetime, JSON, OS, NumPy, etc. We have some plotting packages using matplotlib, and then we'll use the base map package that we've talked about before. This base map package that I mentioned, we showed briefly on the overview about what we're going to be doing over this course, and we'll dive more into this package in this particular module. All right, so we have our crisis map here that we've been using. Note that I've added a new field for place. Now what this is, and I encourage you to update this as well, is the center of the particular area where your event occurred. For instance, if this is the Boston Marathon bombing, you might put the into the Boston Marathon. If this was Hurricane Harvey, you might put the middle of Houston. This was the Paris November attacks, you might put the middle of Paris, these kinds of things. We'll use this for plotting. This will actually tell us where we'll put a dot on a map that says where this event occurred. And then we have the bounding box data here, which we extracted, or I used the website I showed you in the slide to pull out the lower left longitude and latitude and the upper right longitude and latitude. And then we'll pull out our crisis time and go ahead and set which crisis we're going to look at. We'll read in the relevant tweets that we pulled from Module 5. And now we can actually look and see how many of these 5,000 relevant tweets contain GPS information. So as I mentioned, this is going to be quite rare even. So with this 5,000 tweets, we would expect there to be, at most maybe 50 to 100 geocoded tweets. And what we'll see actually in this particular case is that number is quite a bit lower. I'll show you how to plot these tweets and then filter based on a bounding box and then do some analysis on this filtered set. But for now, the first thing we will do is filter out tweets and keep only those tweets that have a coordinate field within them. Is there a tweet coordinates field? Well, all tweets have this high-level coordinates field. And so the first thing we'll do is filter out tweets and keep only those tweets that have a coordinates field within them. This is what this coordinate filter function does. It returns true if coordinates exist in tweets and whatever the contents of this coordinate field are. So we'll go ahead and filter out all of these relevant tweets using this coordinate filter function. So this will give us however many geolocated tweets there are. We can print out the count. So here we see there are only 6. This is about 0.1% of the tweets in our data set. Now that's one kind of tweet. As I mentioned during the slide presentation, there is a kind of geolocated tweet that has GPS coordinates about the specific location where that tweet was posted. But there are also tweets that are much more common that have a referenced place name. We lose some specificity here because I don't have to be in the city of New York to reference the city of New York in a tweet, whereas supposedly I ought to be in the city of New York for Twitter to identify or say the GPS location where I posted a tweet from is in New York. So here what we'll do is extract places or tweets that have place information because these will be relatively more common than geolocated tweets. We have the same kind of information here that we want to only keep tweets that don't have coordinate information because we've already would have kept that here and do have place information, and that place information is not empty. It's very similar to the geolocation filtering we just did. And we see the number of place tweets is an order of magnitude higher than the number of geocoded tweets, but still relatively rare. So here we had 6 geolocated tweets, and here we have about 70 tweets that include some place information. So we can look at the difference in the information that we get from this data. So I'll print out some information here that you can look at. For GPS-coded tweets, we have a coordinate field that we can look at and a place field. But for place-coded tweets, we only have a place field. The coordinates for GPS-coded tweets look like this. This is an actual point on a map somewhere that says this tweet was posted from this position, and then a place name or place information object here that is basically Twitter's version or Twitter's inference about where this tweet was posted from. So it looks at the coordinates and says, oh, this was posted from a city of Braschaat in Belgium, and it has some coordinates about that particular city. Contrast this with a place-coded tweet. We have no GPS-coded information, but the rest of the information that we saw, we still have. So we have a place type, that's a city, where that city is, what country that city's in, and we have another bounding box here as well, which is what we'll actually use for figuring out where a tweet is posted from and graphing it. All right. So now we have a filter about what tweets have geocoded information. This is for the tweets that have that GPS information. What we want to do is plot them on a map. So we want to look at a map of the world and see where these posts are coming from. So we'll look at the coordinates, or we'll extract the GPS coordinates for each tweet in our list of geocoded tweets, and then we'll build the base map visualization using the base map object. So we'll have a Mercator projection again, and we'll look at a very large portion of the globe, again using a lower left corner, upper right corner format that we've been using, where the lower left corner latitude and longitude are here, and the upper right corner latitude and longitude are presented here. So we have negative 60 degrees south by negative 180 degrees east, and we have 80 degrees north by 180 degrees east. So this essentially gives us a map of the whole world, and then we'll identify or include some additional information in our world map just to make it a little bit more legible. Draw some coastlines and continents. We'll draw our lines of latitude and lines of longitude, and then we'll identify where land is versus where water is, and we can set a title. Now, the next thing we do is take the latitude and longitude from our place information. So this is the particular point in space where we say an event occurred, and then we have to use the scatter plot function to place that point on the map. This will place a circular blue dot on the map that says this is where our disaster occurred. We have some large size here since we're looking at a large swath of the globe. Now, for the other tweets that have GPS coordinates in them, what we want to do is convert those from the GPS coordinates to XY coordinates. And we see that we did the same thing here for this latitude and longitude of our event by using the world map object that we created with this base map function. And then putting in the longitude and latitude, note the order that world map expects longitude first and then a latitude value. And here, when we are dealing with the geocoded GPS coordinates of our tweets, we'll do the same thing, where we'll pull out the longitude and latitude posted to those geocoordinates, convert them using the world map function from GPS coordinates to the XY coordinates in our graph, and then we'll split them into XY points so we can use the regular scatter plot function that we've seen, and then we'll go ahead and plot them on the map and then show. Note that base map is kind of slow, so it may take a minute for your visualization to show up. And here we have it. This is a visualization of how many did we have? 6 GPS coded tweets in our data set published here. So we see 1, 2, 3, 4, 5, 6 across the globe. And this blue dot represents where our event occurred. So now we can actually filter out tweets that didn't occur from our disaster area. In this case, we'll use a bounding box around the country of Belgium, since Belgium is not very large. Here we'll pull out that bounding box, create a new figure, and use the base map function with the bounding box surrounding our particular location. So note here we're using the bounding box that we created in our crisis map, but here, scroll back up, we used a generic bounding box that covers most of the globe. We do the same thing that we did before, where we fill continents, draw coastlines, plot lines of longitude and latitude, these kinds of things to make a nice, attractive map. We will convert the crisis location, longitude and latitude, to an XY point using the target map, just like we did in the cell before. And then we'll plot this on our map so we can see where a particular disaster occurs. And the next thing we want to do is build a polygon that will let us filter tweets that occurred within or outside of our particular bounding box. So to do that, we have this target map function, so we convert from GPS coordinates to XY coordinates in our visualization. But we want to do this with points on this bounding box. So we'll look at the lower left corner here with the lower left longitude and latitude. And then we'll look at the upper right corner here with upper right longitude and latitude. And then we can use this array to create a bounding box in terms of a set of points. So here we have the lower left corner, we have the left upper corner, the upper right corner, and then the right lower corner. Then we can use the polygon class that comes with matplotlib with these points to create a polygon that represents this bounding box object. This polygon has a function for checking to see if a point is within or outside of this box using the contains point function. So now that we have a box that says this is the location where our event occurred, we want to look at tweets that occurred just within this bounding box. The next thing we do is take all of our GPS coded tweets, convert them to our XY coordinate plane that we have in our visualization. And then we're going to go through all of these converted points and check to see if that particular point occurs within our bounding box. So remember, we had this bounding box here that we created as a polygon using these corners of our GPS box. So then for any given point with GPS information, we can check to see if that box contains that point. And if it does, then we can add that point to our list of plottable points, which will be this small list of geocoded tweets that we want to plot. And then we will do this scatter function as well to plot those points on the map. Note that we're only plotting those points that were in the list of plottable locations. So this would be only those tweets that were within the area of our disaster. And after a second, you should see something like this that's zoomed in on your particular country or your particular area. Here, as I mentioned, I've zoomed in on the country of Brazil. Again, this blue dot is the disaster, and this red X is where this particular tweet, or however many tweets you have in your data set, was posted. Okay, so now that we have a bounding box that lets us identify tweets within and without a particular disaster zone, the next issue that we have to be aware of is that we have a very limited amount of data here. I showed you how to use the place information to figure out where a tweet was posted from. Here we have place-coded tweet for a tweet coming from Galway, Ireland. But the issue is the difference in format. So GPS-coded tweets have a latitude and longitude, a single value, but these area tweets have information about where, in general, the tweet is referring. So how can we make these two pieces of data consistent? Well, here I am introducing you to a function I put together called flatten box or flatten bounding box that takes a bounding box structure from a particular tweet and then essentially averages these points on your bounding box and gives you back the average. So if you consider a square on a map, this method will flatten that square into the midpoint of that square. And that in general is not the best idea. There are a lot of issues that can arise with doing this sort of default thing, like all of a sudden your location is in the middle of a lake. This is a well-known problem, but we'll use it here just as sort of a simple hack that lets us look at where tweets are posted from. So to do this, we look at a particular tweet right here. We look at the latitude and longitude, and for each coordinate in this particular bounding box, we add the latitude and the longitudes up, and then we compute their average, which essentially says, find me the midpoint of this particular polygon, and we return that longitude and latitude. Now, what this lets us say is take all these tweets that have place information in them, and then use this flattened bounding box function to return a particular location where we can say that tweet has been posted from. And then all the rest of this code right here is about setting up our visualization. Again, we'll use this large swath of the globe and draw coastlines and parallels and meridians, etc. We will use the world map function to identify where this particular crisis occurred. We'll convert the points from GPS coordinates to XY coordinates that we've seen before, and then we will scatter them using the scatter function from matplotlib for just those tweets that have GPS information, and we'll color those red. And then we'll do the same thing for tweets that have geocoded information, and we'll color those green. And then we can plot this image. And you see a lot of the tweets did not have geolocation information turned on, and it appears they primarily came from England. As you see here, there's a large set of green dots there. All right, so now that we've talked about how to plot this information, how can we use this information in an effective way on real data? So in this cell, we'll use the bounding box methodology that I just showed you, looking at the lower left corner and the upper right corner, and building a polygon from this data. We'll make our map nice and pretty using continents, drawing coastlines, meridians, etc., and figure out where this particular event occurred using the target map function that we just created. And then we'll build a polygon for filtering like we did above, and we will create a polygon from this, and then we will filter out tweets that occur outside of this polygon. This would be tweets that reference a place that is not Belgium or not Brussels, and then we can print out some information about this. So now we can scatter, or we can use a scatter plot to say here's where all these posts were coming from, and then we can say how many tweets were posted in a particular area of interest. So if you're looking at a high population city, or you're looking at a large swath of land in an underpopulated region, we can get some estimate the data here. Okay, and we convert data from our data set to these XY coordinates as well to check and see if the bounding box that we created contains these points, and if so, then we add them to our list of plottable points again, and if we do not, if this bounding box does not contain this information, then we just move on to the next tweet. Then we go ahead and plot a scatter plot of tweets that mention places. Do note this is not tweets that have GPS coordinates associated with them, and then we can see how many geocoded tweets or place-coded tweets occur outside of the target area versus within your disaster zone. And you see here we have a few tweets that come from our particular country. So we have one tweet that's up here, another tweet down here, but mostly our tweets are concentrated within Belgium, which is nice. That's what we want to see. Okay, so now that we've built a list of tweets and visualized where they occur, what we want to do is build a list of these tweets that we've identified, or that the classifier that we created identifies as relevant. So again, we want to look at this bounding block to separate tweets from within this region versus tweets from outside of this region. Create this bounding block to say, or to check this information, and then we can look at the difference between GPS and place-coded tweets. We'll create GPS information for both of them. So here we use just the point within this tweet. Here we have to do a little bit more and say, well, given some tweet. So we use this flattened bounding box function to take the coordinates of our bounding box in a particular place and then collapse them down to an XY location. And then we can merge all of these together and say, here are the tweets that did occur in our country of interest or our area of interest, by saying here's the spatially relevant tweets and spatially relevant tweets using GPS codes, and we can merge them here. We'll go ahead and run that. We should have spatially relevant tweets and GPS code tweets together, so we should have about 8 location-oriented tweets, and then we can pull out some information about these tweets as well. So we can look at the first 10 or the top 10 tweets that are from a particular area and print out information about them. So here we have, please do not post pictures of victims out of respect for relatives, a tweet that appears to be in Flemish or Dutch, another tweet that appears to be in Dutch, and then lots of thoughts and prayers and condolences for the victims in these tweets. But we have some additional information here, like this person, Sandra Beauty, talked about we are okay and where they are in relation to Brussels. And we have a lot of mentions of prayer for Belgium as well, which is relatively standard in response to disaster. All right, so this shows us the tweets that were from this event in terms of spatially co-located with the event in some form. But now we can also look at media from within that target. So if you think about a moment of social unrest, the content being shared from within a protest may be more impactful or more useful or more interesting than content shared from some random person 1,000 miles away in a different state. So what we can do now is use this geocoded bounding box information that we have and look at just media posted from within that area. So here we use the HTML image and display stuff that we used in the previous module to display things. We get tweets that have media in them, which is going to be the number we saw before. And then we can look at the number of geolocated tweets that also have media. And we see a couple of tweets that are within the country of Belgium and shared media and tagged this information. So you have this one talking, or this is a kind of a satirical cartoon, and then this one here sort of explaining that enough is enough about these tax. And then we have, again, the tweet content as well. Okay, so that gives us the tweet text during a particular disaster in a particular region. And now we look at the tweet multimedia in a particular disaster in a particular region. Now can we sort of bring our two modules together by looking at geospatial and temporal relevance in tweets. So we use the time format that we used before, and then we're going to build our frequency map of tweets per minute. And here we have the frequency map of tweets that include GPS coordinates per minute. So there'll be relatively few tweets here. The same thing that we did in Module 5, looking at time series. We'll go ahead and fill in any gaps in our data set in these sets of lines. And then we can say when our start and stop time was for tweets that were from this area. So there are about 299 minutes that we can look at, or about 5 hours, and some probably very small number of tweets. And now we can plot these tweet locations on a map, or make it a relatively large landscape view map, and say, well, here are all the sorted times that we have. Here are the number of tweets in that particular moment that included geolocation, and that included this other variable here. We'll make some tick marks so we can actually read this map. And then we can say, since we are looking at essentially counts, we can say X data is however many bins we have, or however many X coordinates we have in our data. And then we can plot the regular post frequency list. This is the number of relevant tweets in a particular time frame. And then we can post the GPS coded tweets as well. So these are relevant tweets in a particular time frame and coming from a particular area. And then we can print those out as well. And what we'll see is this green line is all about GPS posts, and this blue line is the number of posts in a particular minute. And you'll see that GPS coded tweets here at the bottom are exceedingly rare. So don't bank too much on having good access to this information. All right. Now, as I mentioned for the homework for Module 7, essentially I update this notebook with the disaster you selected, and then you can run this notebook and identify the interesting results from this notebook. All right. As always, if you have any questions, feel free to post to Slack, and I will answer them as soon as possible.